We've entitled our panel today, The Road to Scotland is Paved with DNA. I think you could write a song about that if you gave it a minute. As many of you know who do clan research or family genealogy, the paper trail for your ancestors ends sooner or later. And it's a very frustrating experience if you've been there. But there is another way. Little less than a year ago, and what a year it's been, I came across a simple but elegant tool called Snip Tracker, created by Dr. Rob Spencer, and I have to say, it really got me excited. SNPs are mutations that occur from time to time in our genes. You could call them markers in time. They allow us to extend our research much further back into the past than was heretofore possible. And they help answer those two really big questions that we've all thought about. Who am I and where did I come from? With that, I'm going to keep my comments mercifully short, which I think our panel will appreciate. And we have a lot to show you today. So with that, I'd like to ask our panelists to introduce themselves, and then we'll get on with the show. Rob?
There we are.
Hey.
Hi, hello everyone. Thank you so much, Keith, and all of the organizers for the opportunity and the invitation. This is a real treat. I'm retired now and writing software, and that's, as Keith said, how we became acquainted and have enjoyed working together over the last few. My career, a degree in physics, then a PhD in biochemistry, and I worked in the pharmaceutical industry, mostly at Pfizer, for nearly 30 years. Left that, worked as a software developer, and am now retired. So I love the genetic genealogy. It brings together some of my background in biochemistry and love of working with large data sets. And for me, it's a place as a retiree to do citizen science. It's a lovely area. And I've had the great pleasure of meeting Keith and Maurice Gleeson, who's been hugely helpful ever since I started this only three or so years ago. Enough about me. Maurice?
And you are Robert Spencer, are you not?
Robin.
Robin Spencer.
Thanks, Rob. My name is Maurice Gleeson. It's delightful to be here, and congratulations to the organizers for organizing such a wonderful online seminar and conference. So I am a medical doctor. I'm a psychiatrist. I also worked in the pharmaceutical industry for 20 years or so. And then I became addicted, as many of us have, to genealogy. And I've been an avid genetic genealogist for the last 10 years or so. I organize the DNA lectures in Dublin and Belfast every year, termed Genetic Genealogy Ireland. And many of the lectures are available for free online, so do check out the Genetic Genealogy Ireland YouTube channel. There's quite a few presentations there that have a Scottish topic. And we also have quite a few there relating to Irish clans, which are a nice comparison. So I have also a variety of different surname projects, Gleeson, Farrell, Ryan, they're mainly Irish surnames. And that's given me a fairly good grounding in how to use Y-DNA data to help further surname research and extend it into the era of clan research as well. So I'm particularly interested in Rob's presentation. Sue, how about you?
Thank you. My name is Sue Miller, and I am the Director of Programs for the New York Genealogical and Biographical Society. And it's a pleasure to be here today, especially with such experts on DNA. I'm more on the family history line and really do help people with their genealogy. And that does include DNA testing, including autosomal, that we'll talk about a little bit, and the Y-DNA. I'm not an expert there, but I am learning a ton. And I'm very happy to be on a panel with such great, knowledgeable people. So, Keith, back to you.
Wow, that was seamless. Well, we're going to take the show over to Rob now because he built this sort of elegant contraption, I'll call it, an innovation, sorry, Rob, that I was really taken by. I have to say, it got me excited.
We're freezing, or I'm not hearing you, Keith.
Not getting me?
Fine. I can hear you fine, Keith.
All right, good.
The connection's fine.
Yeah. Okay, where was I? I bumped into Rob's elegant little contraption. I shouldn't call it that. It's an innovation, actually, less than a year ago, as I said. And we're going to turn the show over to him because really it's what this show is about. We'll go from there. As you'll see, we have a PowerPoint and we'll just all sort of jump in as we've rehearsed before. So Rob, over to you.
Okay. Am I showing the slides, Jamie?
Yes, sir.
Okay, super. Bit of presentation here because we know we have a diverse audience. And so we're going to do a little bit of background on DNA. We're going to go fairly quickly through it. It gets amazingly deep, as you may see. So hold those questions. There may be some that are technical and many that are, you know, connections to clans and all. Let's hope this is fun for you. Anyway, carry on. Okay, hang on.
I would ask you if it's possible, please, Rob, to maximize the slides. There we are.
Is that it?
Thank you, sir. Thank you.
Got it. Thank you, sir. All right. You're probably familiar with DNA testing. A lot of people these days get DNA test kits, especially for the holidays. It's a nice family gift. And people are probably familiar with it for filling your family tree, you know, finding out who my great-granddad was, breaking through brick walls. But we're going to focus more on its capability, which is lesser known, especially with the Y chromosome, to do some incredibly deep history. And that the data set is now getting so complete. So many millions of people have done this kind of testing. The science and the data have just exploded. And it's coming together now. It's not perfect, it never will be, but it's coming together where the DNA, as Maurice said, is overlapping paper and traditional genealogy. And it's fascinating. So we're getting connections. And our theme here will be not from Scotland to the present so much, but how you got there in the first place. So a bit of introduction. There are three types of DNA to mention. And you may hear about these, so we want to clarify what they are or what they're not. These are given to us by Mother Nature. We didn't choose them. They have different properties. And we as genetic genealogists make the best we can of the properties that we're given. Especially with mitochondrial, you'll see we wish we had more, but you know that's just the way the cookie crumbles with the biology. Anyway, the dominant type of DNA is called autosomal, and that's almost all the chromosomes that you're familiar with, the little spindly looking chromosomes. And that is 99% of all your biological functions that make you the human being that you are. It's also the DNA you think of when you think of, you know, I have my dad's hair and my mother's eyes, all that sort of thing. Half this DNA is from your mother, half is from your father, autosomal, and that happens every single generation all the way down. So it mixes and dilutes thoroughly, very, very quickly on a genealogical time scale. It's also the kind of DNA that is the least expensive to test, typically $60 or so these days. You can do a cheek swab, and that's the kind of thing people give as holiday gifts. It's very, very common, autosomal. It's powerful, but it has limitations, as we'll also see in a moment. Mitochondrial, we won't talk about too much. I see there's already a question about how to trace through female lines. Just as a peculiarity of biology, there's a little tiny piece, only 16,000 instead of 3 billion, base pairs of mitochondrial DNA that's part of our aerobic metabolism. It's absolutely essential for life, can't live without it. But as it comes out, it comes only from mother to child. Men and women have mtDNA, but only mothers carry it forward. It's not in the sperm, it's only in the egg. It has certain limitations because it's so tiny and it's under heavy, heavy selection pressure because of its importance to life. MT testing costs about $140 typically these days. But the star of our show today is on the Y chromosome. The Y chromosome is a puny little thing compared to all the others. Its really only role is sex determination. You think about for the moment, it can't be anything else because women don't have it. And since women are a perfectly viable, very healthy half of our species, the Y chromosome can't carry anything that's essential for life. It wouldn't work. So it really only carries a tiny switch. And of course, it's only through the male line. So father to son, to son, to son, to son, to son, to son. It's a different technology involved, and it's about $350 US these days for the most useful test. Some of this will become clear. Here's a sketch, again, describing these types of DNA. Autosomal in yellow, there's you at the bottom, and then your parents in red and blue, then your grandparents, there are 4 of them, then 8 great-grandparents, and 16 great-great, and so forth. Autosomal, because it dilutes by a factor of 2 every generation, half from mom, half from dad, only goes back about to 1750 or 1800. Back to great-grandparents or thereabout. It doesn't go any further back because the information is diluted away, essentially, right? From each of your grandparents, you can only get a quarter of your DNA on the average. And it goes back a quarter, an eighth, a 16th, a 32nd. You go back a little further and then there's nothing there, nothing reliable there. So autosomal is great, back 250 years or so, and it covers all your lineages. It doesn't matter your mother's or father's line. Any zigzag you want to draw on your family tree is equally, at least on average, equally populated in your autosomal DNA. mtDNA, look at it, it goes 1800s colonial, feudal, Roman, Neanderthal, all the way back. Same with the Y-DNA, all the way back. 200,000 years is about the age of Homo sapiens. That's why we don't actually have to draw the line there. We could keep going back to when we split from our friends to chimpanzees and further back, Neanderthals earlier than chimpanzees. But we start the clock 200,000 years ago. It's kind of mind-boggling even that, but only on these very narrow lines. A way to think about it, analogy is autosomal DNA is like a candle. It shines in all directions, but only for a short distance. Y and mtDNA are like laser pointers. They go a very, very great distance, but they only illuminate a little tiny spot. So when it comes to things about what Andrew was very nicely presenting about clan identity and that sort of thing, the Y-DNA is terribly powerful and important, and because it also aligns with our surname tradition in our culture. But it is only a teeny tiny fraction of the total DNA that makes up you. It's just the one that we happen to be able to see. But never forget, Sue's laughing, she knows this very well. Never forget that it's only a little tiny piece of who you are. It just nature just deals us this funny card that says that's the one we can measure. Okay, a little about autosomal, because you may have done this and it has some value to us. So we'll go through it kind of quickly. This is my map. And very typically with these Christmas packages you'll get, you get back and people endlessly chatter. I'm an admin too, I failed to mention that, on one of these very large, very, very active websites sponsored by Family Tree DNA, the vendor, one of the major vendors. And this is the kind of report you get back when you do an autosomal swab. What's my ethnicity? And it's described in terms of blobs. Now, when we started this some years ago, the blobs were the whole size of Europe, the whole size of China. As they get more and more data, the blobs get a little smaller, and the companies know that people identify with nationalities. DNA doesn't pay any attention to what Sweden is or Germany is, but people do. And so they're trying to define the blobs. But the important thing to note here is the resolution of these blobs is at best the size of Ireland or Scotland, or a bit of France. And you'll notice the European Jewish is the whole of Eastern Europe. So the resolution is poor. It's certainly not up to saying what clan am I. You're doing well if the percent Scot that you are aligns with anything that you think is true for you. So I like this analogy. Let's hope it works for you. So how does that ethnicity thing work? Well, you've all been to the paint store, I assume, if you've ever bought a house or redecorated an apartment. Each of us is a paint chip in the back. Pick your color, that's you. And there are thousands and thousands and thousands of us, every color you can imagine, across the back wall of the shop. But when you go into the paint store with your chip, it's the same as bringing your DNA swab to the company and asking what my ethnicity is. When you go into the paint store, the guy in the back there he is, does a little magic, and that's important. And he gets a printout that tells him, well, it's 1 milliliter of this, and it's 2 mils of that, and it's 5 mils of this other color. And he's got about 8 or 10 master colors back there. And when he has the numbers all correct for your chip, he squirts those in, shakes it up, and that's the best possible match for what you are, your color. DNA ethnicity works the same way. The companies, through a lot of detail and typically on the order of a couple of thousand people, they do the best to identify as pure Polynesian Islander or Aleutian Indian or some northern part of China, or of course, Northwestern Irish and so forth, and Scottish and so forth and so on. They have maybe now about 20, 25 cans of paint, master colors, and they, through computer method, take your DNA swab and figure out what is the best fit, the best mix of ethnicities that will give the color, the DNA sample, that fits you. And that's all they do. It's this computer algorithm running on ethnicity. Now, again, a thing about autosomal, and I mentioned it again a little bit because it is inexpensive and many of you may have done it. But again, here, the point of this slide really is, it's good, but it has limitations. And it's not going to go as far, at least today, as we want to go and as we can go with a Y-DNA. So this is a very good paper. The reference, academic reference in Proceedings of the National Academy of Sciences is on the bottom of the page. And these folks asked 2,500 people who could all assert that all 4 of their grandparents lived within about the same 20 or 30 kilometers of each other. In other words, the same village or town. And then they took DNA samples from all of them. It's very hard to assemble data sets like this. It's quite a lot of work just to get those people together and to check their bona fides. But then what they did is so that's all the paint chips. Then they deconvolve it, if you will, in the computer and say, well, here are all the master colors. Each little different symbol type is one of the master paint colors required to recreate the diversity of the DNA that we saw. I'll point out for contrast, the lovely thing about these data sets is we can compare one to another. So Scotland gets added meaning historically if we compare it to Ireland, if we compare it to England, or if we compare it to other parts of the world. So in this case, look first at England, or at least most of England, and it's all the same red circles. This tells us that even though England has had historically a lot of stuff going on, Anglo-Saxons come in, Vikings come in, Normans come in, it is, DNA-wise, it is incredibly mixed. It's a thoroughly stirred pot. And in autosomal terms, you really can't pick it apart very well. It's literally a melting pot of DNA. Now, Cornwall and Devon are a little different. Bits of Wales, North and South Wales are different. And of course, you're looking at Scotland. And Scotland, we can see about 1, 2, 3, 4, 5, 6, 7 or 8 different DNA types in Scotland, and similarly in Ireland. Now, I'm not going to go into, I'd leave it to Keith and others. We have timing problems. I mean, this data set, because it's everybody's grandparents, is a snapshot in time of about 1880, when grandparents were born, typically. So it's, there's all kinds of questions about, oh, can I identify these with this or that ancient kingdom or early clan? Well, yeah, maybe yes, maybe no. And it's a lot of fun to deal with that and pick it apart. But even so, in the 1880s, here we have a snapshot of identifiably different DNA groups. And Scotland and Ireland are notably less mixed than England, which we could talk about maybe later in the Q&A if you want. Carry on? Okay. So we're going to let me shut up and let the others go. And I think I'll leave the slides on if that's okay, Jamie, and we'll just open the mic. We have a couple of leading questions, and we could probably take them from the online tool as well. Just 5 minutes.
Guests will be able to submit their questions through the Q&A panel at the bottom of the screen.
Thanks, Jamie.
Yeah. I think Maurice should have this, actually. Doesn't mind.
Well, I think these are very interesting questions. The first one has, the second one actually is particularly interesting. Are ethnicity results useful? And yes, they can be, but one has to take them with a huge grain of salt, if not an entire cake of salt, because several reasons. First of all, these are estimates, ethnicity estimates, and this is made very clear by all of the companies that produce these ethnicity estimates. And the other thing to be aware of is the fact that these will change over time as the companies improve the algorithms and the statistical programs that they use to actually calculate these estimates. Another reason why they change, of course, is because the databases with these companies are getting bigger and bigger and bigger. So for example, about 5 years ago or so, we had maybe 5 million in the database. Now, putting all the databases together, we've got close to 40 million people who have done these type of autosomal DNA tests. And I've certainly found it quite useful with some of the work that I do, because I work with adoptees and try to reconnect them with their birth families. And I work with mixed race adoptees as well in Ireland. And it's quite interesting when their ethnicity results come back, they are 50% African, 50% Irish. It's very, very clear to see that these ethnicity estimates are spot on. But it's also useful when looking at their matches, because then you can actually use the ethnicity estimates to say which of the matches are on the father's side, which is usually African, and which are on the mother's side, which is usually Irish. And the same can apply to your own particular situation. If, for example, you have a Scottish line, you have a Jewish line, you have a German line, and you have a Japanese line. It would be very easy to figure out which of your matches belonged to each of those 4 lines, just based on the ethnicity estimates with these people. So that would be ethnicity estimates. The value of having lots of fourth cousins. With 40 million people in the database, if you do your autosomal DNA test and it comes back from the lab, you'll have thousands of matches. And fourth cousins are particularly useful if your brick wall is at the great-great-great-grandparent level, because these fourth cousins will all be triangulating back onto that particular level. And they can be particularly useful if that is where your brick wall is. And of course, certainly with Irish research, a lot of Irish records tend to run out in the early 1800s. And that, for a lot of people, is exactly where their great-great-grandparents or their great-great-great-grandparents are. And I have found fourth cousins particularly useful in breaking through a few brick walls that I have at that particular generational level. Sue, do you have anything to add to that?
Sure, I will. Yes, the value of hundreds of fourth cousins definitely can help. Third cousins are even more helpful if you haven't proven certain lines yet, and maybe even second cousins. So depending on how much you've been able to flesh out the paper side of your genealogy first, and you usually will need, with autosomal, the paper DNA, that traditional looking for records to work with the DNA results. Otherwise, you might have clusters of people, but you don't know where they're going to fit across your tree. So it helps a lot to have your second cousins to test if you can find them. And if not, at least your first cousins if you can. So there's a lot of technique on autosomal, but we're not going to spend an awful lot of time on that today. I do want to jump in and just say one other thing on the ethnicity results, that these, again, are estimates, and the companies are continually upgrading and putting new data into their algorithms. So once you get that, that classical pie chart, you will find that over time it will change and become more refined based on the new data that the companies have. And it won't be the same across the companies. All the companies have their own reference populations and algorithms. So it's fun for me, but I don't use it quite as much of it as a tool as maybe Maurice will with the adoptees. So back to Robert Keith.
Quick caveat here. I've tested just for fun with 4 companies now. I was yelling at Rob the other day about this. In one of them, I'm 41% German. In another one, I'm British, quite a bit. In another one, I'm 27% something else. And in another one, I'm 61% Irish. That's the value of, well, I won't say it, but we've got a ways to go. I'm probably one of the unlucky ones who it didn't work out for, but that's what you're giving for Christmas. And people do tend to believe it. So you're kind of, you know, you're back to those Ancestry ads where I thought I was German, but I found out I was Scottish, so I traded in my lederhosen. It's a little, it can be a bit taking you off the track. That's all I want to say.
Okay.
Rob?
Keith, one more thing, just really quickly. I think Jamie is putting a few of the links that will be helpful to people in the chat. So do check the chat for links to the slides and a couple of other things.
Okay. Happy to. Rob?
Yeah, okay. No, I just wanted to mention, apropos what Maurice and Sue mentioned, if you're doing the math and if you're a North American and you're interested in Scottish heritage, and if you're immigrant who left Scotland once upon a time, was further back than like your great-grandparents, you may have figured out and done the math that autosomal isn't going to get you there. Probably. It will help you fill in your what we'll call your colonial family tree. You know, but those of us like several of us now who are admins on these websites and helping people out on a daily basis, it is extremely common for people to do autosomal and figure out through all these third and fourth and fifth cousins, figure out what they didn't know perhaps about their American or Canadian family tree. But the brick wall for a huge number is then, I got to this guy who has a family record in an old Bible that says he came over in 1680 from Scotland or Northern Ireland, and that's it. That's the brick wall. The Atlantic is a huge brick wall, and autosomal usually won't get you across, but Y-DNA might. So let's carry on with that. Now I have to, okay, that'll work. We good, Jamie?
Yep.
Okay, Y-DNA. SNP, single nucleotide polymorphism. Just so you don't have to remember that, we're just keep calling it a SNP. A SNP, that's a little doodle of the Y chromosome on the left, a cartoon. A SNP is just a mutation. A cosmic ray, oxidative chemical damage, doesn't really matter what it is, can cause a change in DNA. It can change to an A to a T, a G to a C, and so forth. Your Y chromosome has 57 million base pairs, of which we use 22 million. A big Y is a product, the DNA product that the males of us have done here. It sequences all this usable part. It's incredible technology. DNA sequences the useful half of your Y chromosome, 22 million base pairs. In that, among that 22 million, there are 260,000 SNPs, like the little red base pair in my DNA cartoon there, that have been identified that are markers that tell us are unique and harmless markers. They don't do anything about a function. They don't code for anything. They don't get in the way of any of our biology, but we carry them along. It's incredibly useful when you think about it. You may have heard that 95% of DNA is junk. That's a long story. It isn't really junk, but a lot of it has, as far as we can tell, doesn't have a function or has no deleterious or beneficial effect. And that all this DNA is like that. So everything we're talking about in genetic genealogy is not about disease mutations at all. So a mutation here is a neutral term to us. It's just a marker. Maybe that's a better way to talk about it. Anyway, and every given man has about 1,500 SNPs that differ from a reference set. This is not like the paint store, so scrub that from your mind. But we have about 1,500 SNPs that are unique to us. Well, it's unique to our very close male line. And this sets us apart. Before I get too confusing, let's just carry on and show you how it actually works. So bear with me on this. You got to put on your thinking cap, have a sip of coffee. We'll only do this. Maurice is laughing. We'll only do this once because we talk about trees and family trees. And this little slide will explain, follow along, how you can take a cheek swab and sequence a chromosome and figure out a family tree from it. And it isn't magic, but it's very clever. So let's say we have 3 guys named Adam, Bob, and Chris, A, B, and C, and we do their cheek swab and we sequence them. And it turns out that Adam has marker BY1 and BY2, Bob has 1, 2, and 3, and Chris has 1. And this is the way it looks to us when we get our results back. Oh, what SNPs do you have? I have this SNP, I have that SNP. Oh, that's not very interesting. That's just on the left, right? So what? Well, the so what is there's only one way. These markers are unique. There are not 2 copies of BY2. There's only 1 BY2. And the probabilities are extremely good that there's only been ever one BY2 happened ever in human history. And with that in mind, there's only one tree you can draw that is consistent with the observation. Because all 3 guys have BY1, their common ancestor must have had marker BY1 on the tree at the right. Adam and Bob have 2, but Chris doesn't. So that means Adam and Bob are more closely related. Their common ancestor, one of their common ancestors had marker BY2 originated with him. And Bob has 3 and he's unique. So he must have a common ancestor that neither of the other 2 has, who originated marker BY3. Everybody got that? No quiz at the end. It's all fun. But my point is, of course, we'll from now on, we'll start to draw family trees, or what look like family trees. And this is how it's done. The computer goes through and assembles this. And here's what it looks like. And it's big. This is the tree of man, and I mean literally man, because this is the Y chromosome. There is a tree, similar tree for the mtDNA, but again, because it's mostly a patronymic society that correlates with the surnames, as well as power structures and all that sort of political stuff in our society, and we get much better data, we'll deal with a Y chromosome pretty much from here on in. So in the tree of man, the Y DNA tree, at the top, and there's a time scale on the left if you can read it. We're going back 240,000 years. And there's a guy called Y Adam. He was a real person. He lived. We know he lived in Central Africa. Adam is just the way academics talk about it. He's not the first Homo sapiens, but he's the first one who's the common, as measured by the Y chromosome markers, he is our earliest common ancestor. All right, he's probably close to early Homo sapiens. The dates are about right, but he's our earliest common ancestor. So he goes along, and when we get to about 50,000 years, there's a well. Let me jump to the bottom. I should have said that right. At the bottom of the list is the present day. This is a family tree. Those blocks are huge, and we'll dive into one soon. At the bottom are 15,000 terminal SNPs, that is family branches. At the bottom of this tree is the individual family level, and often the individual surname level that we'll see. But as we go down the family tree, we can even see some big events here. We see out of Africa, and we see if we follow below the out of Africa branch about 50,000 years ago, all of a sudden the tree explodes to the center and to the right. And that's simply because it's mostly Western Europeans and their descendants, North Americans, largely Australians, who do most of the DNA testing. This tree is actually twice the size, but because we don't have the data and not a lot of men in India and China and Southeast Asia and Africa do testing, we don't see them yet. Someday we will. This is actually mostly a Western European tree, and that's just because of who has the money and the interest in testing so far these days. And we can see down at the bottom, we'll talk more about this later, there are some big events in history that start to become apparent. There's a Bronze Age expansion down below, and we have another big explosion after that. And we can see that there we have big blocks, which we, at the risk of stereotyping, we call mostly Anglo-Saxon, mostly Iberian, Spanish, Portuguese, and mostly British Isles. They're not exclusive, they're not perfect. Over on the other side, you see Finnish, Nordic, ancient Pan-European. But these are all identifiable blocks on the Y chromosome. If you get confused, just remember, this is an enormous family tree. Now I'm diving into that block on the lower right. See, it says RL21 British Isles. Now we're diving into that, and I've recolored it. Sort of mostly Scottish in blue, Irish in green, and English in red, just to show you now we can start to see some history coming in. It's a family tree. All those individual lines start at the top and come down. And we can start to identify markers with surnames. we're getting down to about 1,000, you see on the left, 1,000, 2,000 years ago. The persistence of DNA is so incredible that those of us who work with this think on a time scale that's really different from anybody else. When I hear people talking about clan events, in Andrew's talk about things that happened in the 16th or 17th centuries, I'm thinking meanwhile about things that happened in the Neolithic or the Bronze Age. It's just as familiar because we now have the power of these tools. But anyway, we can see the M222 is largely an Irish marker. It's not perfectly Irish, but largely Irish marker. And we can take the fact of that, which we observe. Why? All these men have this marker. Many, many, many of them claim Irish ancestry. And so there must be something to it. And we can, in fact, map this back onto history and see why that makes sense. What history is needed to make that make sense? Same with L1335, which Keith has as a marker. Why is that? Why do all these men have this marker? They claim they have certain surnames, they claim a certain heritage. What history do we need to deduce to make sense of that? And so forth and so on, all the way across the line. At the very tips of this, maybe you can see the little tiny dots at the very tips. Those are recent SNPs. That could be you. I mean, a man could have originated in him, the next mutation. It could have been his father or his grandfather. On average, in a line, a SNP occurs every 100 years, on average. It's a statistical thing. So that means between you and your dad and your grandfather, a new SNP is likely to have occurred, 50-50 chance between the three of you, a SNP will have occurred. And that will then appear in the databases and will appear at the bottom of the tree in the recent era. That's how good this is getting. So you can see why the bottom of the tree now is overlapping with paper genealogy. You think 1,000, 2,000 years ago, you go, eh. But when we're getting down to the bottom, we're overlapping with paper, and which is, of course, where it gets very interesting. Now, there are big groups in the family tree DNA databases. This is the only company, this is where we've all gone, those of us who apply chromosomes. They're the only ones who do the Y-DNA test, and they very nicely arrange huge projects. They have 10,000 projects, actually. Some of them are surname projects, which are very popular with people, and some of them are geographical projects, and they overlap. You can join multiple projects if you like. So the Scotland DNA project is a very big one. Oh, I'm guessing now it has maybe, what do you think, Keith? 8,000 men in it, probably?
More, maybe more. Yeah.
Maybe 10,000 men in it.
Yeah.
But if we take that as a pretty good sample, random sample, because again, this is invisible. Until we did the sequencing, nobody could ever see these things. These are completely invisible markers. It's important to remember, they don't code, these markers don't code for red hair. They don't code for, you know, skill in the bagpipe, nothing. They're neutral markers. Sue's laughing. So, but here we can divide up Scotsmen pretty fairly into what are called haplogroups. The light green, which is about 60%, is an ancestral marker card called RL21. And about 60% of Scotsmen have this. As we'll see in a little bit, that means that their paternal ancestor arrived in a known place and time in history that is different from the others. That's all it means. But they have a certain history. Amusingly enough, it's called the Beaker people. You may not have heard of the Beaker people, but 60% of Scotsmen have a common ancestor who's a real guy in whom that mutation occurred. He probably lived in what is now northern France or Belgium or the Low Countries about 4,500 years ago. There's a next bigger group in pink over there called RU106, largely considered an Anglo-Saxon marker. John Cochrane has that marker. This is also a big, substantial group in Scotland, somewhere between 10 and 30%, depending how you count. We can pick out the Vikings. Again, why? Because the Norwegians were genetically isolated from other people for enough time, 1,000 years or two in their ancient history, for the genetic marker, a bunch of SNPs to occur, which didn't mix with anybody else. And so we can pull apart R1A Viking markers very clearly. This includes Somerled of MacDonald and other fame, 1100 AD or so, David Hume, another well-known Scot. We can separate them from I1 Vikings, who are more Danish Vikings, very clear in the DNA, completely distinct. Bart Forbes, who is perhaps listening, as well as Alexander Hamilton, have that marker. I2, an ancient one. Bruce Dury has that one. So did Davy Crockett. And I didn't know that interesting thing about the Scottish connection to the Alamo. But there you go. And we'll see that has an ancient history. I can claim the faintest connection on a maternal line to Scotland, but I'm an other. And I can stand in to show you a completely different way how I got there. Okay, let's carry on. So now this is the part that Keith likes, Keith enjoys this the most. We'll do ancient migrations. This is the sort of map you'll see if you look up ancient migrations in Wikipedia, or if you watch a Discovery Channel show, or you get National Geographic. This is the sort of map that you're drawing today. National Geographic, of course, has drawn these maps over the decades, and they get better and better all the time. And since we've had DNA, they're getting really detailed. And the lesson here is now, only in the last couple of years, and it's what Keith likes, a little application I wrote, it can get personal, literally for you. We can draw your path, your paternal path, at some point down to a resolution that at the end of the day is almost within a county or two. That is 100 miles, plus or minus 100 miles at the end of the day, which is the fun of doing this. But anyway, here we see, again, the great migrations of man. We won't speak much more about it, but of course you can see coming out of Africa, you can see large paths going across. You probably know about the land bridge across Alaska and the Bering Strait. Two large haplogroups, Q and C, about all of Native Americans, North and South America, about 15,000 years ago. I'm getting a note. I hope my, okay, internet is wobbly. And there are other lines coming out, but we're going to get much more specific. Now, here's one way. I drew this up, and the others liked it. So here's a way we'll go through. Now we can get a little more personal, and we'll illustrate in kind of a block diagram the various paths we've taken. Now, at the bottom of this is Scotland for most of us on the panel, and thank you to Bart and Bruce and Mike and John and us who had done DNA tests and shared their data with us. So Maurice ends up in Ireland. My ancestry ends up in England, but the rest end up in Scotland. And we all begin at the same place as well. We begin 240,000 years ago in sub-Saharan Africa. The incredible thing is we took different paths. And this, again, it's bread and butter to me now. I've been steeped in this for a couple of years. But it's mind-boggling how recent it is that we can say this and we can make it personal. So you can see that, I will just pick a couple out and then we'll go to the maps themselves. Whereas Bart's paternal ancestry line begins in Africa, goes to the Fertile Crescent. Remember all that stuff in school about Tigris and Euphrates? It was all real and for good reason. Rivers are a big deal in here. If you look, Fertile Crescent, Tigris, Euphrates, Nile Valley, Indus Valley. There's a big theme in here about prehistoric humans and rivers for very good reason. It's a great place to find food. And if you don't find food, you starve. Fishing, animals come down, fresh water, the stuff you need to survive. And that's how far back we are, of course, here. Bart's line carries on, lives in the Balkans for a while, in the Baltic for a while, around the coast, whether that's Scandinavian or Northern German, Polish. This is way before there were such things as countries. There are no names yet, but we give modern names to it. And then Norway for a while, and then over into Scotland. Remember, he's got one of those Viking markers. Pick another interesting one out. Many, 60% of Scotsmen come down the middle of the page there. Fertile Crescent, Mongolia. I don't know if Keith is gone now because he's embarrassed, because apparently a year ago, he told you had Mongolian roots. Well, he's right. So we'll excuse him while he runs to hides. He's getting his Mongolian outfit now. That's all true. And you came roaring up the Danube Valley and end up in Scotland. And then Sue and I over on the side took our own particularly circuitous way. Sue through the Indus Valley up through the Fertile Crescent. And my folks were the last out of Africa, but fairly early into Europe, actually. My ancestors came down the Nile Valley and doodled around probably in the Nile Delta for 10,000 years or more, while most of you were out in Mongolia. That all sounds nuts, right? But we can do it. We can measure it. So now we're going to get to the maps. Early on, I showed this because if you did DNA testing, even 5 years ago, this is about all you could learn. They typically divided you up into groups of 50,000 years ago. We have Paleolithic hunter-gatherers coming out of Africa, heading up. I'm going to put the names on right away. And our representatives today are Sue, Bart, and Bruce. Their paternal lines and maternal lines for Sue took that line. I'm the only representative we've got of the Neolithic farmers. Took a slightly different path, but many, many years later. We can't wrap our heads around these timescales, but they're all real. And then the most recent of all is Keith, Mike, John, and Maurice are what we call the Metal Age invaders. That means a mixture of Copper and Bronze Ages. Again, coming up, all heading as our destiny takes us up toward the British Isles. We're zoom in a little bit more, get a little more detailed. Again, this is similar to that pie chart before, but now I'm showing you it on a map. Remember the pie chart where I showed you the, roughly speaking, the percents of men in Scotland and what their haplogroups were. Now we're starting to identify haplogroups with some of the great invasions or migrations that populated Scotland. Earliest of all, we have the Paleolithic, 12,000 years ago. That's about 15% of Scots today, roughly speaking. The Beaker people, 2,500 years ago, 2,500 BC, sorry, about 40%. Anglo-Saxons, I can't even read it back there, 30-ish%, depending how you count. Of course, the Romans are in there, but the Romans didn't leave much DNA behind. When Romans leave, there's a power vacuum, the Anglo-Saxons come roaring in. Then, of course, the Vikings come in after the Angles and Saxons have settled around. There's no peace in the valley. Vikings come in about 15% today. And finally, the Normans in 1066, and we're into the modern era. So I think, yeah. Okay, we're going to get to the personalized stuff here in just a second, so bear with me. A little more history in a nutshell here. This is like 1066 and all that. 20,000 years ago, this is what that part of the world looked like. Basically, Scotland is under a mile of ice. That's the blue. That's the ice sheet of the last ice age. The ice sheet sucked a lot of water out of the oceans, exposing land. And so the British Isles were connected to the continent in what is amusingly called Doggerland. It must have been something in German. Maybe it's the name of one of the people who discovered it. But it was all connected by land about 20,000 years, 18,000 years ago. 12,000 years ago, the ice starts to retreat. The earth is warming up a little bit. Doggerland is retreated, but it's still there. And our first person up is Bruce Dury, who is our standard bearer for haplogroup I2A, which is, you can see the rough prevalences today in Scotland, Ireland, Wales, and England. These are the first, remember the islands were more or less sterilized. There were people there before, even Neanderthals, but they're more or less sterilized by ice sheets. And so people repopulate 12,000 BC. And the first to do that is Bruce Dury and his cohorts. And here's what they look like. The fellow on the top left, this handsome dude with blue eyes and dark skin is literally a real person. This is Cheddar Man. He is a fellow who lived in Cheddar, which is over in North Welsh English border. His skull was modeled, I mean, a cast of plastic or plaster cast of his skull was modeled for the shape of his face and head, and his DNA was used for the color of his eyes, the color of his hair, the colors of his skin. And some very, very talented forensic sculptors have now done, and they've done this a lot, to say, what did this fellow look like? And that's what he looked like. It's remarkable. They were hunter-gatherers. Why didn't they have light skin? Well, because they didn't have to. Because a hunter-gatherer diet is rich in vitamin D. That's another story we can talk about if you don't know. It's not why skin is dark, it's why it's light. And it's light because later on, the diet got poor and you needed to make vitamin D in your skin photochemically. And so skin had to turn light or die. But that hadn't happened yet here. So this fellow and his cohorts who built Stonehenge 1, sketched at the bottom, hunter-gatherers, and these are the first people into Britain. And so let's have a look. Oh, I'm going to jump. Now this is where I may bobble it a bit. I have to go here. I have to go to new share. Bear with me. How's that, Jamie?
That's absolutely fine. That's fine. Thank you.
Super duper. All right. So now, well, I said Bruce, so let's do him.
This is Sue.
I know. Well, we'll start with Bruce. I said Bruce, so here we go.
Gotta give the women equal time.
Oh, we will. We'll do the best we can. Anyway, here's Bruce's history. His paternal line, literally, see the little walking man there? He's walking out of Africa.
Snip Tracker for all.
Yeah,
you.
This is
Snip Tracker.
Live software. I'm going to stop the animation so we can slow down and talk about it. 100,000 years ago, there's a land bridge across the Red Sea. You can see across it easily anyway. You could almost swim across, unless the currents get you. The Persian Gulf was land then. And these folks this is the deep Paleolithic, the old Stone Age. They hung out for a long time in the Fertile Crescent, but they're still hunter-gatherers. Now you see they're overlapping with Neanderthals, if you can read that. You may know, I have 2.5% Neanderthal DNA. Most of us do. This is when people overlap, Homo sapiens overlap with Neanderthals. So some of that Neanderthal nookie could have happened with Bruce's ancestors. Could not have happened with mine, or no, because the timing is wrong. But we can already say that interesting bit of history. And if they carry on through there, history changes. We're going to switch to Europe, zoom into Europe. And here he comes. You may have heard of the Gravettian period if you've studied that sort of thing. These are the earliest bits of art we have in the Old Stone Age, little Venus figures and the like, and flint arrows and so forth. These are the people, again, Bruce's ancestors, paternal ancestors, who are doing all that, crossing Europe. In the Old Stone Age, the glaciers are still there. You can see the Ice Age is still there. I can't imagine what it's like to try and go up the Danube Valley when the Danube is filled to the brim with freezing cold water from the melting glaciers that cover, all of northern Italy and Switzerland and cover all of northern Europe. It's just astounding, but they survived. And then it says that they could walk across. There's no distinction now of the British Isles. They could walk across, and indeed they did, and populated the British Isles. We will have a look at Sue to be as fair as we can. It's nothing about Sue, it's just some empty DNA. It's not that complete. But we can say for Sue, her maternal line, her mother's mother, came out of Africa, a different place actually, slightly. Mitochondrial Eve is not the same, is not the mate of Y Adam, but it's a more of a definition of the markers. And this line comes out of Africa, similar sort of path, but they noodle around in the Indus Valley. Why do we know that? Well, because archaeologists dig up skeletons and they sequence the DNA of ancient samples. We don't have many, we have a few hundred, but we can pin this. This is all based on real science and real archaeology now. You know that we've sequenced the whole Neanderthal genome. It is now, there are factories and there are labs in Copenhagen and at Harvard and a few others in the world that have moon grade clean rooms that take ancient DNA samples, especially in the skull, part of the bone of the skull, where DNA survives now for 50,000 years easy. And it's now routine, amazingly. So we have thousands and thousands and thousands of whole genomes now from ancient DNA. And it's filling in the blanks. Again, Sue's line, similar sort of track, comes up through Europe, also Gravettian period, also when the glaciers are still there, and again gets to the British Isles when Doggerland is still there. Okay, let's go back. New share, keynote, ding, 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 okay. And let's go to play. Excuse me while I fool the tech. Yeah, okay. Next up, racing through this, the Beaker Invasion. What the hell, Beaker Invasion? Oh, you'll get it if you haven't heard of it. But in terms of the population of Scotland, this is the biggest deal. This is, again, 60-ish% of all Scotsmen have an ancestor, like I mentioned before, who was a real man. We don't know his name or anything. Names didn't exist 2500 BC. Surnames come in far, far later. But a man lived probably in northern France, Low Countries there, about 2500 BC, whose surviving sons and grandsons and great-grandsons and all end up populating 60% of Scotland and even more like 70, 80% of Ireland, which is kind of amazing, but there it is. So he's in the late Neolithic, early Bronze Age, and this is one of the most important migrations we have in the history of the British Isles. Keith likes this view of it. Same picture. This is in Snip Tracker, showing when we get to the marker L21 and we look at all the descendants, we can see that there are some later ones, people who claim, let's say, Swedish ancestry or Spanish ancestry, but the vast, vast, vast majority are British Isles. That is, say, you know, England, Wales, Scotland, Ireland. And that's L21. That's what tells us the simplest connection inference is of the guy was a Beaker and lived in, basically is one of the founders of this migration, this invasion. Excuse me. Just in time for coughing, I'm going to turn over to Keith, who can talk to this one, if you will, while I have a sip of coffee. Thanks.
Don't have too much, Rob. Right. I love this slide for one big reason. As you can see, we're all the same tribe, more or less, okay? It spreads over several thousand years. This is the Bronze Age. We are the Bell Beaker people. We bury our dead we cremate them and bury them in beakers. I once had the experience of taking a beaker out of a kist on a farm in Scotland. We had permission, of course, and it disintegrated in our hands, just dust. But I actually got to hold one of their burials for a few minutes. The tribes come up, they all come up. They're all DF13 in this case. As you can see, we get to Britain. What intrigues me most is you see O'Neill and you see Maurice and myself and the Stuarts all being part of the same tribe. And it's not till we get to southern Scotland or thereabouts, northern England, that the tribes, one goes north and one goes west. These are important tribes. The O'Neills, of course, become the MacDonalds of Ireland, the most dominant clan, the High Kings. The Stuarts, obviously, you know who they are. This says that we were the same tribe. And we've had all these arguments over so many years, and right down to New York, and the Irish need not apply. But we actually are the same people, very much the same people. And if you go back to that slide with the triangles, the blue-green circles and triangles, you remember that it was the upper part of Ireland and the western part of Scotland that was indeed L1335 and did that. So fascinating tale. We're not very different at all. We're very close. Maurice, you have anything to say? I'm not hearing you.
There we go. No, I think that's a very nice summary of the fact that we all come from the same single man who developed, or one of his descendants developed the L21 SNP mutation in his DNA. And that has now passed all the way up through England and across into Ireland, up into Scotland. I think it is fascinating, really, that we can all trace, a lot of us certainly in Britain and Ireland can all trace our ancestry back to this one man in Europe who lived around about 2300 BC.
Right. And I would point out, if you can see in the bluey green there, the dates, a couple of interesting things is you all get to the end because you ran out of land at about the same time. And again, we have ancient DNA samples and we, by the way, I didn't talk about it before. SNP mutations carry, in a sense, their own timing. It's a little rough, but when we're this far back, it's actually pretty good. We can lay date to a SNP in statistical senses. And so these, I should mention, I didn't mention before, the Beaker people, yes, they made characteristic pottery. Well, I'll mention them in the next slide. But they also had horses and they moved fast. They were essentially nomadic and they moved, I mean, going from 2100 BC, 200 years to get up there is really fast because the people who had been there before them were there for 10,000 years and didn't move much. So in the scheme of things, they are rocketing up the island and they're all you know, they're on horseback and they're nomads and they all run out of gas, meaning they run out of land at about the same time. It's not really surprising. So, you know, very simplistically speaking, the Stuart line there runs out of land up in Aberdeenshire, what is now, you know, what would become many years later Aberdeenshire, and the MacGregor line ends up on that side toward the islands, the O'Neills in Northern Ireland, and Maurice's line down toward Southern Ireland, all at about the same time.
And Rob,
yeah.
were they the people, remind me, who had the wheeled cart too?
Yes.
Okay.
Yep, they had horses, wheeled carts, and they had bronze swords, and nobody else did. Ouch. This was in broad terms, this is the most brutal invasion you can imagine. We won't go there too much, but they replaced over 90% of the DNA in 200 years.
The male DNA.
The male DNA. Sorry, the male DNA. Yeah, they killed the men and took the women. I can't say it any other way. Sorry about that, but there it is. I mean, if you thought clan wars were brutal, you got nothing on this. Nothing in later history compares to the Beaker people, because they were the only guys in the block with horses and weapons, and they used them. All right, and this handsome dude is again a forensic reconstruction. He's a real guy, a real Beaker person, and blonde hair and blue eyes and light skin. Why? This is Neolithic. They had farming as well. They brought with them from the European path grains. And the great thing about agriculture and this wheat and barley kind of things they brought with them, it's much more reliable source of calories. And so you can have more babies that survive. The downside is, and they didn't know this, is that it's very poor in vitamin D. And vitamin D is made in the skin. And the only way, and it only takes about, so light skin appears only about 8,000 years ago. And there's a very good reason why that's coincident with the beginning of the Neolithic diet, which is very poor in vitamin D. And so, you know, evolution has a tremendous selection pressure for that. And so all the Beaker people also bring in this appearance. And there's some of their characteristic pottery, their bronze tools you can show, and a reconstructed sketch of what they lived in. So let's show a couple of paths now. I'm going to do the same thing, jump out of the tool. If I can, jump back to there. We're going to do this a couple of times, so bear with me. And now I'm going to show the Beakers. Now, again, I've got all three Beaker gents here together, and they all start, now we have a different track, if you remember. We're coming out of Africa in a sort of a similar way, because we do. I mean, this is overlaps. I'm the only one who's different, as we'll see a little later. They all come out, they're noodling along. We're in the Paleolithic, the Old Stone Age, and we skirt up to Mongolia. Now, what the heck is with that? Why would anybody go out there? And the reason is you've got to think Old Stone Age. You've got to think hunter-gatherer. And our parallel here is American Indians. American Indians we know because we, as Europeans, observed them for a while before we sadly took all their land and killed them. They would follow the buffalo about, better part of 1,000 miles every season from, what was then Texas, Oklahoma, up to Montana and back as the buffalo migrated because they depended on them. The same thing must have happened here. We don't know exactly what animals, but there are animals that migrate on these paths. And so ancient man follows them, follows the migration paths. It's the only kind of way you can think about this. And again, the scope, if a buffalo or a caribou can easily migrate 1,500 kilometers or 1,000 miles every season. So these distances are not at all outrageous when you think of it that way. So it's just by chance. So here they come, ancient North Eurasians. There's some evidence for old digs that they took the south route around the Caspian. As they come up the Caucasus Mountains here, their ancestors pick up something. They pick up bronze for the first time. Our little man is here 17,000 years ago. He's getting bronze for the first time. And by the time he gets here, at this point, they were eating horses. Horses are a domestic animal and they were eating them. But about 15,000 years, by the time we get up to about 11,000 years ago, we're out here, they had learned to ride them. A really enormous change, and if you want to call it in technology. It makes all the difference in the world. They're also developing wheeled carts, as Sue said, and they have bronze swords, riding horses, and wheeled carts all the brakes are off now, and they go nuts. This is called the Yamnaya tribe. We won't show it, isn't to our story, but they go down to India. They go both east and west because they can. Their ancestors are in India and become part of the Brahmin caste. Why Brahmin caste? They had the swords and the horses. It stays with it. In our case, in Europe, they go up the Danube, which is an easy route in. Here they come. They're roaring up the Danube. They come into Central Europe. The names, the cultures change, but genetically, we see it's the same people. Become the corded ware cultures, the Beaker cultures. The skull and crossbones have appeared, which reminds us that humankind is now starting to develop what we call cities, groups of 10,000, 20,000 people living along a riverbank. You got that many people in a place, what do you get? You get plague, not very nice. But we also see that come in, and that also plays into the patterns we see in the DNA, by the way. And again, they all come over. At this point, the resolution is not so good on the map. We won't worry about it. But again, 2 of our lines end up in Scotland, and Maurice's ends up in Ireland. Okay, and by the way, they're already there by the Roman era. So again, snips carry along a clock, and we can already say by the time the Romans arrived, you'd already gotten to ground, if you will. So amazing history we can see in the DNA. And you too can learn this, and we're here to help you as part of our ad. You know, Keith and Maurice and I and Sue are all here to help you should you do DNA testing and want to help interpreting it, because we're all learning really quickly these days. So let's go back. That was the Beakers. Let me jump back to that. Oh, it's not showing what I want. That should be showing what I want. Yeah, okay. Next invasion is the Romans. Skip over the Romans, 2 reasons. One is they didn't bring much DNA with them. The Roman invasion of the British Isles was more of control and authority. It wasn't huge numbers of people really in the DNA. And secondly, of course, they didn't get that far into Scotland. That's why they built the walls, because those Picts and all those guys were not worth the trouble. So the Romans don't affect our story very much, DNA-wise. These next guys do. When the Romans leave town, about 410 AD, that had enough, they pulled out. Well, they left a power vacuum. The power vacuum was very quickly filled by Frisians, Jutes, Angles, and Saxons. We summarize this, the Anglo-Saxon invasions. These are all a Germanic people. And we know, again, from DNA, as well as traditional archaeology, that we're mostly talking about where I'm showing from what is now Denmark or the Low Countries. And John Cochrane and I are your representatives for this. I'm EV13, which is really funky and very rare. It's only about 3% of people in the British Isles, even lower in Scotland. But John is RU106, which was one of the largest of the markers, DNA markers, for the Anglo-Saxon invasions. Again, here's one of those forensic reconstructions. This looks like somebody you're going to see in a subway in London, and you don't want to talk to him. They had beautiful jewelry and elegant weaponry, as shown by that reproduced helmet. And they lived in actually decent looking little thatched huts. So this is the Anglo-Saxon invasion. And we're going to jump out. We're going to do this only a couple more times. Bear with me. And we'll jump back and we'll show specifics for our Anglo-Saxons. I'm going to jump out again. Now, as we look to John Cochrane's fathers track, it's the same that we saw for the Beaker people, because it is. Because here they go. Same line, out to Mongolia. Remember, this is only the Y line, though. This is only the father's line. Out to Mongolia, same people with the horses, eating horses, riding horses, getting bronze swords, and up into Central Europe. At that point, John's line splits away from the Beakers. His Beaker ancestors stay in Europe for a couple more millennia, and only cross over to Britain with the Anglo-Saxons 3,000 years after Keith's ancestor was already there. my folks take a different line. I won't bother to switch over to mine, but you can see the line going up the Nile Valley or the Red Sea. My paternal ancestors hang around in the Sinai for tens of thousands of years. It's a nice, again, river delta, good fishing, fresh water, nice place to be. They hang out there for a long time and then cross over into Europe, across Turkey, Anatolia, about, 4,500 years ago. My ancestors crossed in, 8,100 years ago, crossover. And it was my ancestors, again, who I mentioned a while ago. I'm the only representative here of the Neolithic farmers. So many other people, not just the E line, but also J lines and G lines and others, are the first to bring grain and goats and cows and sheep into Europe from the Fertile Crescent. And it was named the Fertile Crescent for a good reason. That's where all these things were first domesticated. So my guys are hanging around in the Danube Valley when the rest of you folks come barging up with your damn bronze swords and carts and horses. And you probably confronted my paternal line and said, you join us or die? And my ancestors said, sure, I'll join. And we end up in Central Europe. And we remember, these are invisible markers. And we end up in Central Europe and all cross over with the Anglo-Saxons when the Romans leave the door open behind them into the British Isles. So history in a crazy nutshell. Let's go back to, I have to go back. And I think I should be okay there. Yeah, okay. One more jump. Very soon after the Anglo-Saxon era, we have the Viking era. They're just kind of like Anglo-Saxons with better boats, in a sense, somewhat different culture. Bart Forbes is our stand-in for that, and Summerled, he isn't here today, but he has to stand in for the other. There's a recent, very nice paper. It's called the Fine Structure of Scotland and the Isles DNA, that has made what was suspected really, really clear. And it's kind of remarkable. In the DNA, as I've drawn it here in the cartoon, you can really separate Norwegian from Danish Vikings. I never remember having heard the distinction before. You know, when I learned about Vikings back in school, it was all about the boats and the swords and that sort of the history. But we can tell now much more specifically where they're from. So we can say that Bart, who has the marker I1A P109, is a descendant of Danish Vikings, as were most of what we consider in the Danelaw in that part of British Isles history, while the R1A line and another I1A line there are Norwegian, and they come around and populate that part of Scotland, the Isle of Man and Northern Ireland, where the markers are very, very clear and genetically completely distinct. This is a fairly big part of genetic history. Here's a handsome dude. He's a real Viking, dug up and reconstructed the way they lived. That lovely boat in the lower left is actually only a mile from me now. I'm in Mystic, Connecticut, and that is a reproduction made with authentic materials and authentic methods of a Viking ship. And the goofy Norwegians, and this is only a couple of years ago, actually sailed that thing across the North Atlantic. It does not have an engine in it. They literally sailed and rowed it across the North Atlantic. Yes, the Norwegian Coast Guard in a proper patrol boat was just behind them in case they needed help, but they didn't. So they did it for real. And my hat's off to them. And it's a lovely boat. I've been on it several times. Vikings. So last time we're gonna do this jump out and have a look at the Viking track. Let's go to Bart. Once again, we'll back up. We all start in Africa. We all start in the same place. Now, Bart's a little different from the 60% of you who he did not do the Mongolian tour thing. His paternal line. So when you think about it, this is really amazing. Remember what this is doing. It's saying the person you might be sitting next to, or at the next clan meeting, the next Highland Games, the person sitting next to you has a paternal ancestry that could be thousands of years and thousands of miles different from yours. You never knew it. It's absolutely true. It doesn't mean anything today. It's just fascinating history. It doesn't affect who you are. I think Andrew is exactly correct. That your identity is is who you are, how you think, what you've done with your life. But nonetheless, this is a real part of us, and we can read it in the DNA. So just like we saw earlier with Bruce, Bart's line here is very old in Europe. They do overlap with the Neanderthals. They do overlap with the glaciers are ahead of them. But then they noodle around in the Baltic for tens of thousands of years, which is fine. And they only cross over as Vikings much, much later in that era, again, when the Anglo-Saxons calm down or run out of gas, and the Vikings develop their ship technology and get tired of their lousy, cold environment and want better pickings in the British Isles. And that happens then, and that's the end of that. So let's go back. That was the last jump, and we're back. The Normans get, again, like the Romans, and again in my real silly thumbnail history here, they don't bring a lot of DNA, or at least it's impossible to track because it's so mixed in with the rest of the European melting pot. We can't really tell Norman DNA, even though I'm in a huge project and people bring this up all the time. I'm not sure there are any really reliable markers for the Normans, again, because they're mixed in with the same people as the Beaker people before them and the Anglo-Saxon people before them. You can't tell them apart in the DNA. But in any case, their invasion is much more about a small number of people with administrative and aristocratic power, but not so much about bringing over whole families and populating. So let me again take a breather and open the floor. Keith, you want to kick off?
We've got 16 chats. Has anybody been checking any for questions or anything? I'm just curious.
No questions
Yeah.
at the moment.
There's quite a few links that, from the presentation that were shared in the chat. So,
Okay.
and Bruce Dury reminded us that the shelf under the North Sea is called Dogger Bank, hence Doggerland. So thank you, Bruce, for that.
All right. Maurice, did you have something?
I've just been answering a few questions in the Q&A section as we go along. The third question here, what fraction of my ancestry does my Y path represent? It only goes back along your direct male line. So for example, if you go back about 10 generations in your family tree, you're probably going to have about 1,000 ancestors at that generational level. And your Y DNA is going to tell you only about one of them. And it's not going to tell you very much about 999 others at that particular level. So that's just to make the point that Y DNA only travels back along a single line. But of course, you can research any surname in your family tree as long as you test the right cousin. So one of the names in my family tree that I was particularly interested in was Spearin. And I had to go back to my great-great-great-grandfather, find a direct male line down to a third cousin that I had never met before. And I said, hi, I'm your cousin. Can I have your DNA? And he said, sure. So you never know when people are going to say, yes, they're interested in being a part of this wonderful adventure. And as long as you can find the right cousin and test that cousin, you can research any surname in your family tree.
And a good point to that would follow up with an earlier question we had is that's one way that women participate in this. The mtDNA has some limitations we won't go into anymore, but finding a male relative on the line that matters to you historically could be a brother, a cousin, and for them to test, they may not be interested, but if you are, just piggyback on their history is your history. For a brother, certainly. So do it that way.
And that's where the autosomal DNA can help you find the right cousin, that with the paper, to see if their line is lining up to what you think the genetic ancestry will be. So
absolutely.
As opposed to the names.
Yeah, absolutely. And I certainly have found quite a few cousins using autosomal DNA and have identified people on the direct male line of interest, and then I've approached them for Y DNA testing. So in many ways, autosomal DNA was the introduction to finding the right person to test.
Yep.
There is one other way you can do that. If you run your Big Y, which is a test we're all big fans of around here, yes, it's a bit more expensive with Family Tree. You get put on the block tree, a favorite of mine. And what this does is follows your paths all the way down to the present, to your terminal, your last SNP, last time you mutated. And it puts the other people that match that SNP in your box with you. You then go to your project administrator, us, and we talk to you. And if you see them on the up and up, we'll probably give you their email addresses and you can get in touch. So it's just that's the second way. Autosomal, as we said, is good to a point, good for cousins. These are people who probably were pretty near your family not too long ago, depending on how you want to date your end SNP. So there's that.
Keith, on that, do you want to explain a little bit more for people who aren't familiar with it about what a project is, a surname project, and who the managers are, how that works?
Okay, yeah, it's pretty, in the beginning, some years ago, we only had the STR test, that's the other test. When you paid for your Y37 or your Y, whatever it was that you took, Y111, you got this massive page of numbers. That's what you see when you join a project. And you look at it, and we had people's heads spinning for years. Rob, Maurice, I think you had the same situation. What do these numbers mean? There's thousands of numbers here. We had a discussion about this, Rob and I, a couple of days ago. They give you some things, but not others. The people in your, it's colorized, and there's people in your circle who are colorized, who have similar STRs to you. They're forensic markers, really. They're just saying that you are of this male group. I think it's another way to say it. But we had a lot of silly questions come along with that, some really sillies, and I fielded them to everybody. Things like, does this make me Rob Roy MacGregor? Or how can I be Rob? I want to be Rob Roy. That's the MacGregor. That will haunt us till the day we die. Other ones were, gee, I'm not where I'm supposed to be. I'm an Or, but I'm not a Viking Or, and I look like a MacGregor. What does that mean? And a lot of consternation in the early days. No one really knew, I think, quite how to interpret it. So a lot of banter went on. With the advent of SNPs, I think we all agree SNPs were a giant step forward. Suddenly we had a lot more ammunition, but you have to do your SNP. To do SNPs, you need to pay a bit more money. A lot of people got ticked off at us in the projects because I just paid $269 for my Y-DNA. Well, actually, you got to do another test. So we had to talk about it. The agreement amongst us is that you have to do both. You can get away with the Y37, the standard test that Family Tree offers, and it will get you some things. But then if you really want to be in the game here, you got to pay for the big Y. And once we get the big Y, as Rob said, you saw how much was in that big Y, and we can tell you a whole lot more about yourself. That's the game, folks. By the way, if you test with somebody else, other companies, sometimes there's compatibility with Family Tree, but most of the time there isn't. And now you've got to pay more money if you want to get into the surname projects, which were wisely invented by Bennett Greenspan a long time ago. So that's my commentary there. I'll pass it back to Rob.
Okay, thanks.
Or anybody else.
Just follow up for a moment on Keith. The other reason we're going to talk about this at the end, perhaps. The other reason to go with a large vendor, in this case for Y-DNA, that means the company called FTDNA, is that you want to go where all the other people are because you're looking for matches.
Mm-hmm. Yep.
So if you go with a little teeny tiny vendor who has only a couple of thousand people in it, the odds of you having a rare match with somebody who's useful to you is really low. So go with the guy who has millions of people already. Seems funny, but it is really is important with genealogy. All right, so I think we're off again. Now it gets interesting. Clans and DNA. So, and Keith has promised to defend me if I misstep here. Maurice is laughing. We talked a lot. Anyway, remember, I'm a scientist, and my name's Spencer, for God's sakes. So, but in my simplistic point of view, what defines a clan is shown here. Very, very simplistic reading of history. Scottish, more or less, largely military political allegiance, to some extent territorial allegiance, and there is a role, of course, for male lineage. I'm not saying there can't be female, but emphasizing male more or less. Irish, as I read it, slightly more emphasis on territorial and farming allegiance. People whom you could trust in your clan were people who would help you with the harvest, more likely. Of course, there is a military aspect to it, defending against those other guys, but it was largely more about cooperative behavior in farming, and again, a bit of male heritage. The point of this slide, though, is why DNA. Why DNA knows absolutely nothing about that cultural history at all. It is only male lineage, nothing about female, only male lineage. So it's an aspect of clan definition, but it's a extremely well-defined, narrow biological part of the definition. Now, Maurice has nicely encoded it this way. His link is at the bottom. We also have live links at the end of the slides if you find the slides online, and I know Jamie sent around the links. And he's identified 3 legs. I put it in terms of a 3-legged stool because you need all 3 to stand up. 3 legs of a clan signature. And that is if, and he would allege, I'm not going to put too many words in his mouth though, if you have DNA and location, territory, and surname or paper pedigree, all more than random, all significantly correlated, then it's more likely that you're looking at a clan, if that's fair to say. The point is DNA is only one aspect of it. Surname and pedigree and locations are also an intimate part of clan signature. He has other things down the bottom, branching pattern and ancient remains. If you can get them, it's fantastic. Actually, I shouldn't run over that. People are, I know I'm in contact, have been working again with a very nice fellow in the Isle of Man, and maybe others as well, but I know he has been actively seeking both the legal permission as well as the funding to exhume a skeleton of an alleged Norse ancestor on the Isle of Man. And if he gets that permission, which he may well, and they do the DNA testing, again, the risk is it all works and it shows that none of you is related. On the other hand, if it works and it is what you think, then you have an incredibly strong reinforcement of the archaeological history with the genetic history. I should note, by the way, because I'll come on this at the end of my slides, the surnames, DNA, and locations can apply to any family, not just a formal clan. Again, there's nothing here necessarily about that sort of clan history. Again, I want to spend, I'm jumping around a little bit, but this came up earlier. I think Keith mentioned a bit earlier that DNA can help you. I would never go so far as to debate with Andrew Morrison about what is or is not a clan, but it can help you in this sense. And I just want to illustrate technically how it works. And I specifically mean big Y DNA. Here are the elements we need. That's you in the bottom left there. And I'm not saying what your surname is. It may be maybe Smith or Jones. I don't know. That's not the point here. The point is you, and it has to be male, on the bottom left does a DNA test. You don't know your line. That's the question mark, the unknown line. But somewhere else in the world, there is a clan member, a modern man, who has a good paper pedigree that we trust, and who has DNA tested. And that modern fellow has SNP markers, and I just made up some names here, RM456, and he has RM123, all right? Bear with me. We know, remember I also said, without telling you exactly why, it's all in the statistics and the math of mutations, that SNPs also carry with them the ability to be dated reasonably well, actually. It gets better and better all the time. So we could say, in my little cartoon here, that RM456 is a few generations before our modern clan member there. But we could say that RM123 is about 1,200 years ago. That's the kind of thing we can say with some confidence, just from the DNA alone. All right. Now, let's say you test, and let's say you have marker 123. You don't have 456. And this is the kind of thing that a lot of Americans, Canadians, Australians might do DNA to find out. What it means is then you may or may not know, there would have been a historic chief. You may or may not know that person's name, depending on which clan it is. You may not, you just know there must have been such a person, perhaps. That's all you could know. But if you have marker 1, 2, 3, you know that you descend from someone who you have a common ancestor with a modern clan member 1,200 years ago. That's the simple fact that you know. If you have marker 1, 2, 3, and so does the other guy in red there, the clan member with paper pedigree, and he has 1, 2, 3, you have a common male ancestor 1,200 years ago. And that's the only thing you can say, but that's a fact. Now the rest of it then, and I'm certainly not going to get into it, is the interpretation of that as clan membership. But again, you have a common ancestor 1,200 years ago. It is consistent with what I've drawn. You can't draw the tree any other way that's going to work. You don't have 4, 5, 6, so you're not recent. Nobody's saying that there was a, what we call an NPE, an out of wedlock event or an orphan adoption event. We're not saying that at all, because that would be around 4, 5, 6 in more modern history. No, we're talking about old history, 1,200 years ago or so, which is old enough to say it had to be, if there was a historic chief who I've sketched it, it probably had to be since that time. All right. So that's what you can say. Keith is saying I hope that'll be good enough.
It's enough.
That'll pass.
So you can come from the chief without knowing it. That's probably the magic of this.
Yes. We don't, in many cases, we don't, as you know, Keith, your clan is an exception that you can put a name to the chief. In many cases, you can't.
Yeah.
Or in a DNA sense. But again, this is all you have to know. Okay? Keep moving along and leave time, because there are going to be some puzzle questions about this. This is another view of all Scottish male DNA. It's the same sample I showed you before. I've illustrated now what's called a dendrogram. A dendrogram is a family tree that is wrapped into a circle because it's too darn big to see otherwise. So in this case, the rim of the circle is today, and the center of the circle is 200 generations ago. So 6,000 years ago. And I've put a time scale there for you. From about, 8 o'clock to noon or to 12 o'clock, all that third of it are the L21s. You descend from the Beaker people, as we talked about. And in that, we can see white space, who I've labeled 222, M222, and L1335. These are two great big identifiable, call them families if you want, but they're ancient. They go back, again, a very long time. And they are, I'm not going to say they're clans. I got to use the word careful. They're clades in the DNA sense. So the M222s are all, have common ancestry with the Unil since then, who arose, since that marker arose. The 1335s, and Keith and I have talked about this. I'm not going to say it's proof, but it's very good circumstantial evidence that this marker arose in the right time, place, and lineage for King Alpin of picked to Scottish transition fame. Keith.
Yeah, this is a good one. The Alpin, by the way, that's under my name is Alpin MacGregor, president of Clan Gregor Society. His cousin, by permission, I'm saying this, by the way, is our chief, Malcolm MacGregor. So they are close cousins, and you can see we're all kind of close. But the Kenneth MacAlpin, son of Alpin, is a much bigger story. I can't tell you how many Scottish people I know want to descend from the guy who united the Picts and the Scots, historically, supposedly, we think. It's a big one. It's a big search. Lots of people want to be Kenneth MacAlpin. Well, that L1335, frankly, is pointing right at it. The time is right. The date is right. I know Rob likes to peg to famous people. He said the first thing he ever said to me, just about. But it does work in this case. In fact, it works beautifully in this case. Yeah. M222 again, O'Neill, pretty good.
Another thing to point out here, though, is we can see, by the way, we can see in the bottom, Somerled, MacDonald, we see the R1A, and we see the in purplish there, we see the Danish Vikings, the I1 M253, and so forth. All those groups are represented in this way in the DNA in a different way. Another thing to point out here is, though, there's a lot of thin gray lines that drop everywhere that are not part of these identifiable groups. Well more than half. Guess what? Those are Scotsmen who are not, they might be legitimate clansmen, absolutely, not my place to judge, but they are not part of these big identifiable groups. So it's all in the details. Maybe the point is there are only a few genetically identifiable large descendant groups, and I've pointed them out here. Now, this is a slide that Andrew Morrison alluded to what I want to talk about here. I picked Mackenzie at random just because it worked. I could pick any surname. I could pick my own, which has nothing to do with clans. It's as English as they get. It looks almost the same. All family groups look like this. In fact, any group of men almost at random looks like this. Let me detail what this is. Again, it's a family tree. It's a dendrogram, which is essentially a family tree as far as we're concerned, constructed by computer from your DNA patterns. Modern people, each little tiny red dot across the bottom is a real person, is a kit number of a man who did a DNA test. We have a time axis on the left. We have today, we have 500 AD, and we have 1000 BC. An important line there is a line in green going across. I labeled it surnames. You see that? The surname line, that's maybe what, 13th century, 14th century, something like that.
Yeah.
That also happens to be largely the time, I want to say the clan formation era in many cases. Good, thank you, Keith, you're nodding, that's okay. Well, in history, you know, here's my point. If you are in one of those blue, there are certain patterns in there. We see a pattern in the blue blobs where you can clearly see, as in a family tree, a related group of men, okay? Those are clearly, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9-ish of them, all right? Those are clearly identifiable clades. If you're in one of those blue bubbles and you're a specific guy, and there's another guy in another blue bubble, a different one, you have a common ancestor, but your common ancestor lived before the name Mackenzie existed, before there were surnames. If your lines join between your blue bubbles far enough back, you join in the Neolithic in Central Europe. If you're me, way the hell over there, our lines join in ancient Anatolia or the Levant, for gosh sakes, 50,000 years ago. So any joining in a family tree here above the green line, we generally consider not related. In the DNA sense, yes, DNA gives us all the detail you could want for our relationship. But for practical purposes, the surname line, and which nicely coincides here with the onset of clans as identifiable entities, for good reason, surnames. Above that, joining above that, we generally consider not related. So what I'm showing you is people named Mackenzie who have joined the DNA Mackenzie project. There are 8 large groups who are not genetically related in a traditional sense. And there's an equal number of men who don't have a blue blob at all, who are singletons, what I'd call singletons. And Keith knows very well what these are like when you run one of these projects. You can't find any matches for them. And they, in fact, are half of all men, okay? And that says nothing about Scotland. This is any group of men you want. It's in the statistics of Homo sapiens reproducing, living and dying. Really, it's that fundamental. In any group of N men, it says at the bottom, you will find about N over 2 separate lineages, where lineages is defined by cutting a line across at about the time when surnames arise. So if I have 100 men, I'm going to have about 50 different lineages. If you're share a lineage with another guy, that's identifiable. And you have a common ancestor within the era of surnames, and you might be lucky enough to have a paper trail that can prove something of interest to you. If you don't, you might have that surname, but for any number of reasons we've talked about, adoption, military advantage, there are 100 good reasons why you might have a surname, even though you're in a different genetic line from someone else. This is one of the hardest things for people to wrap their heads around in any group. And I've been doing this for a while now as a very active admin. And certainly when you have clan history, which is very, very, very important and has very strong traditions, it may make it even a little harder for one to wrap their head around. But it's not special. This is just the way human reproduction, life and death are, in the way that human lineages stop and grow.
Well, very good. I just want to remind us that we've got about 12 minutes in our time, and Sue has pointed out we have quite a few questions.
Okay. Well, they're going to come thick and fast. Let me run. Good. Yeah. Thank you. Let's dive in. I picked these again. This is another dendrogram. Zooming a little, I turned it 90 degrees so you can read it. This is, I picked this again for no good reason, except it's a very pretty data set. Again, this illustrates how DNA can show you eras of history in a single glance that you may never have imagined. And it's completely non-judgmental. DNA is not judgmental at all. If you read down the right-hand side, if you can see the names, we have the red dots are real men, and these are the names of their best known earliest male ancestor. So this is not their name. This is not the name of the modern man. This is what he believes is his best earliest known ancestor. So on the top bunch, we see a bunch of Morrisons and one Walker. In the bottom bunch, we see mostly McCown, or I'm not sure I'm pronouncing it right, or obviously like McCune or McGowan related names. So if you look at this, you'd say, I have two groups here. I have Morrisons and McCowns, related names. Now let's go back and talk about 3 levels of relationship that the DNA screams at us with. If we go back to the joining branch on the left, there literally was a man who lived about 940 AD. We don't know, he didn't have a name yet. This is before there were names. But we know, we know when he lived, we know where he lived, because he probably lived about where these clades of modern Morrison and McCowns live today. I'm not sure where that is. It might be Ayrshire, I don't remember correctly.
The Isles.
Okay, the Isles. But probably lived around there, because as we know, people did, they rode their horses and swords, and then they tended to kind of settle down for the most part. So there's a man who lived there about then, and he had 2 sons, literally 2 sons at least. And those sons were special in that they didn't know it, but their sons would survive. And their sons and sons and sons would survive. Most die out, of course. Lines die out. But just by chance, they had lines that survived. One of that 2-man's sons, his grandchildren's many, many, many generations later, lived in a time and place where they took the name Morrison. I don't know why. We don't know why. They might have been the original Morrisons. They might not. That's an interesting thing to try and figure out. Don't know. The other son, maybe he met a pretty girl in a different valley. We don't know, but moved away and ended up taking the surname McCown, and on and on and on and on. In the DNA, there's a particularly good case here, but we see it a lot, and it matters to 90% of the people who are in FTDNA, because 90% of the people who do DNA testings are North Americans. If you look on some of these, you'll see James Morrison, Pennsylvania. You'll see David Morrison, Tennessee. The best that these men know for their ancestry is American. They don't know the name. The best they can do is get to the guy who crossed over, maybe from Ireland, maybe from Scotland, and had the name Morrison. But the DNA shows you that typically the American expansion is another explosion, because the living conditions here were better, basically free land at the expense of the Native Americans. So you see a burst of people coincident with the time after 1620, when the American experiment begins. So in a single glance, the amazing thing about DNA, we can go all the back from what we don't consider related, but the DNA shows us it is, back to 940 AD. We get to a surname era, and we clearly see what now become 2 clades of surnames, and we can also see American expansion. This motif happens over and over and over in Scottish history, or all history, actually. I think this is my last slide. Just to point out the scale of this. Again, I'm not judging, trying to be careful with my language. But if I look up on Wikipedia, and I look up traditional clans, now some of these, of course, have clan chiefs, and some do not. but we have some 350 traditional clans. If I do a computer search of all the available data through the kind of groups that I've showed you there with the Morrison accounts and before Mackenzie's, I come up with about 1,000, what we could just call SNP families. They have all the DNA pedigree of a clan, but we don't have the rest of the clan pedigree. And it's just interesting, the scale, we have 3 times as many of those. And this is Scottish DNA. These are men who are joined the Scotland DNA groups. 3 times as many have a DNA pedigree that is typical, but they don't have the traditional clan association. So to my mind, at least, you can beat me up, there's an opportunity to find history that we don't know yet. And Maurice is laughing, sure. But there's history we don't know yet. That's all I'm saying. We have, in many cases of the DNA, we have 17th, 18th century ancestors, we have locations, we always have modern descendants. There may be some interesting history to attach. The DNA is pointing out to us. We just don't know yet. Next steps, and we're done. And then after this endeth, let me just check the next slide. Yeah, after this endeth. So I'm going to cut over to everyone else and we'll end it here. We'll begin the panel discussion again. Thank you.
Who's up?
Great. I might as well start off. I think the last slide is really particularly telling, Rob. The fact that we've got 3 times more kindred groups, if you like to call them that, SNP-defined kindred groups, than we do actually have named clans. And it just really points to the fact that probably a lot of clans that were present historically have just been lost in the mists of time. And it really points to a very exciting opportunity for clan research, Scottish clan research, Irish clan research, in that it may very well be possible to search for and find some of these lost clans that are there in the DNA quite clearly, but are possibly not in the literature that has been traditionally accessed by researchers up until this point.
We all have a lot of work to do, don't we?
Genealogy will see us out.
Keep us in business. Not that we get paid, but
I think we do want to get to a couple of questions, right?
Sue, yeah. Why don't you pick a few?
Yeah, just at the top, Barb and John were asking where they could access the Snip Tracker. The link has been reposted along with some of the others. Jamie, thank you for reposting a number of the links. And there is a link to the slides, as Rob has said, which has some active links. So you'll be able to get a lot of these too. So
nice, nice. You can play with Snip Tracker on your own, by the way. If you have your SNP or any research, put it in. Rob is, like I said, considered the women equally as the men. That's a very nice touch these days, Rob. And you can learn a lot just looking at the pictures. That's how it happened to me. So.
And on that point, actually, Renee Comer asked a very important question, is about, can women get involved in these studies? Women cannot do the Y-DNA test because women do not have Y-DNA. Y-DNA is only passed down from father to son, and therefore it's only on the direct male line. But I always encourage women to join my surname projects. So if you are a female O'Malley, join the O'Malley project. And there are several reasons for this. Firstly, women are frequently the family historians, possibly more often than men. Secondly, women can actually help recruit men to the project for Y-DNA testing. And thirdly, women can give autosomal DNA and mitochondrial DNA to these Y-DNA surname projects. They don't tend to be used very often, but in certain circumstances where you're trying to bring a group of people together, then the autosomal D can be very, very helpful. So I certainly do encourage women to join surname projects. Some project administrators don't allow it, but I find that the more people you have in a project, the more momentum that is built up, and the more successful that project moves forward in terms of recruitment and in terms of people just contributing to the general discussion about what do the results mean, and advertising the project among their family and friends.
I'd like to say one word too about the project administrators. You all are volunteers, right? So we all have to be kind to all the project managers and know that they're volunteering their time to help us out in solving the genealogical and historical questions that we have. So thank you all for doing that. I have to say that. I'm not a project administrator, so I just benefit from what you are all volunteering to do.
Pay scale's great. Do we want to take any more? I know John said to me that when we're done, we have to say this concludes our presentation. I don't know if we're ready to say that yet. We have had our time.
We've got one or two more, I think. And Maurice, you had one from Lorraine that you thought you might want to answer live.
Yes, that was in relation to Renee Comer's earlier question about can women get involved in projects, and I was certainly, yes, I would encourage women to join, or at least apply to join some of these surname DNA projects. Some project administrators will say no, but I think a lot of them will say yes for the reasons I gave.
Right. And in that case, Lorraine had, she's administering her brother's tests. So she can actually join with her brother's tests, even though she's the contact person,
right?
To your point. And don't forget that men can test for mitochondrial DNA. Men do inherit their mother's mitochondrial DNA, but don't pass it on. So if that's of interest, that's an option for people. And the only company that does that at this point is Family Tree DNA.
There is a question from Glenn Moyer as well. He says that he did a Family Tree DNA test 6 or 7 years ago for a first cousin. Did quite a lot of the family tree, tracing back to Scotland in the 1600s. She had passed, sadly she's passed away now, but she has a GEDCOM. He has inherited all of her information. So what does he do with it, and how does he, can he get any help interpreting this? And the answer is yes, because as Sue, as you were saying, the project administrators of all volunteers, and they are a source of incredible information. So they're a wealth of information from the project administrators. And for this particular situation where someone has done a test and you have Scottish ancestry, you should join one of the larger Scottish projects, like, and I had one up here just a few minutes ago, but what's it called? Well, there are a lot of Scottish projects out there. In fact, if you just Google Family Tree DNA, Scotland, you'll actually get a list of all the various Scottish projects. Some are specific to Scottish surnames, some are specific to just the Scottish clans, and others are just geographic projects based in Scotland. But if you join your DNA up to these projects, then contact the project administrator. Their contact details are on the website, and all you have to do is then drop them an email and saying, I need help interpreting my DNA. And the other source, of course, for information is Facebook. There are a lot of Facebook groups out there, all of which are manned by volunteers eager to help because they're just as addicted to genealogy as we are. And they will be more than happy to assist and help you with interpreting the DNA. And you can get a lot of this advice for free. You don't need to go and hire a professional genealogist, but there are professional genealogists out there if you do want to use them. So Google and you will find.
And there are also many webinars, conferences, programs like this. And this is a perfect time to be learning online and gathering as much knowledge as you can. So I applaud you for that, Glenn. Go out there and keep learning.
Apparently we do have a little bit of time. We just saw that go by, so we could look for more if we wish, I think.
Keith, this is John Belisai, your MC. Can I ask a question?
No, John, you can't. You're only my boss.
Now, after I ask it of you and the panelists, you may regret letting me do it. I notice everybody has very scrupulously avoided using words like Celt, Celtic, Gael, Strathclyde Britain, and all the rest of these ethnic groups that we know from the old historians went to make up the Scottish people. Now, I assume that they're all branches of the Beaker people, but nobody actually said that. Can you speak to that?
I'll take a first crack and then leave it to Keith. Yes, L21, RL21, you will often find discussed as a Celtic marker. The trouble I have, and that's true in the sense that it accounts for what, 80-ish% of Irishmen and 60-something% of Scots, and it's the right place and time, and we understand the history. My trouble with it is illustrated by the fact that there are more Englishmen with L21 than any of the others. Of course, there are a hell of a lot more Americans and Canadians with L21 than any of the others too. But take the English. There are more English with L21 than there are Scotsmen or Irishmen. Well, one, bigger population. But here's the thing, L21 in England is very, very prevalent, but it's only maybe 30% of the population. Why? Because we saw in those cartoons, the English, more than the others, for geographic reasons, were invaded more frequently later. So their L21 is diluted by Anglo-Saxons, by Vikings, by Normans and Romans and all of that. That's the only reason that it's called Celtic. Not because it originates in the Celtic lands, but because the rest of Britain, namely England, is diluted. So to me, it's a kind of a bogus marker. I don't know if that helps. Keith?
Yeah, there's also a lot of talk about, is Celt actually a genetic thing, or is it a culture, or is it a tribe? And I think a little of that has to come in, because you see that it's really one constant wave of adjustment from one society, one culture to another. You have Yamnaya, and you have corded ware, then you have Beaker, and that gets into Scotland and such. And then you have, at one point, you did think L21 had to do with the Celtic moniker. I don't know if it's as Celtic as it is invaders, the Iron Age invaders later on, but I think it's been misused a lot, let's put it that way. And I think you have to be careful. We're gonna have Bruce Dury next, and I think he's talking a little about this, but your derivations will matter on what you've learned, what you've seen on paper, and then maybe then trying to figure out the DNA. It's a tough one. It's a tough mark, a tough label.
Jean Manco did an excellent talk on who are the Celts at GGI 2015, and that's on YouTube, and I've just put the link in the chat panel. And she really just described them as a hodgepodge of different groups. They weren't one identifiable tribe, if you like. So I'd certainly encourage you to look at Jean's presentation. She's also written quite a few books on the Celts as well. And I'm sure Bruce is going to fill us in on more information as well in his talk.
He says he's going to hack them to pieces. I'll go with culture. Bruce, before you start, I'll go with culture. How's that? I'm not going to do race, and I'm not going to do
no, I agree with Keith.
Could you all then say something about the Pictish marker, if there is one? Is that an R1b? Or not?
You want it, Rob?
Well, it's certainly not R1b. R1b, just to be clear, goes back to the Mongolian thing. So no, it's the same argument I made about L21. You know, it's kind of you got to know what you don't know to understand why it's not R1b. R1b is 2/3 of all European men.
Right.
Period. Right. Yes, that's Pictish, but it's enormously more than that. So it really is not a good marker for it. Again, R1b originates out in Mongolia way back whenever the hell that was. If you want to do a Pictish, it's going to be a mix, but probably L1335 is a part of it. I can't judge. Keith, you're better than me at saying, is there likely to be some Viking mixed in there as well as Beaker?
Well, the admixture will, yeah. I do think if you've got to try to put it down to one, you've got to give it L1335 as it splits from M222. Again, as I said before, they're very closely related. But the dating comes in, you know, it's the Bronze Age we're talking about. And it's a big age. It's a very wide age, 2600 BC to wherever you want to put it, 200 BC. So it's yeah, you have to take all that into consideration when you say picked. remember, it's Eumenides of the Romans in 300 AD who gives them the name, and it means painted people. So they didn't even put a name on it until the Romans. So yeah, Picti, painted people. It could have easily called us Caledoni or Dumoni or whatever, any of the tribes there, but that's the one that's stuck because he wrote it down.
But you've got to be careful of the DNA, because, you know, somebody who wandered in could have joined the Pict because he thought it was cool or because he had to, and it was genetically totally different. But he may have painted his face blue and done all the rest and been a Pict, but not in DNA. And we can't, it's not our place to judge.
All right. Anything else?
Thank you all very much. This has been more than interesting, incredibly fascinating, very educational. We could carry on for another 2 days about it, I'm sure. I don't know if you're all up for that, but on another occasion, we'll take this a little bit further. I want to thank you all, our panel, Keith, Rob Spencer, Maurice Gleeson, Susan Miller.